how to determine if a function is quadratic. Okay? If you guys recall from last year, a quadratic function makes what shape on a graph? Parabola, that's right. So you may have something like this, or something like this. Okay. Both of these would represent a parabola. No, not. You may have, in an equation form, f at x is equal to, you need to have some variable, so it could be 3 over 4. The variable has to be to what power?
2 squared.
That's right, it has to be squared. Okay. So the variable to the highest exponent must be squared. If it is squared, then therefore it is quadratic. Now what about this other one here? This one's to the power of 1. Shouldn't it be linear? Why not?
Because the thing is overpowering it.
Sure, that's one way to think of it. This is overpowering it. It's a larger one. So always look to the variable with the highest exponent. So if it's squared, it's quadratic. Now let's say they've given us coordinates. We could plot all of these. What we're going to do is the same thing we did to figure out if it's linear. We're going to do first differences, and then something called second differences. Now, we didn't quite talk about this last time, but in order to do these differences, your x values, and we're going to talk about which is x and y, we're doing speed and braking. So our speed is our independent variable, and braking depends on how fast that car was moving, right? The farther it takes us to brake, probably the faster we were going. In order to do first and second differences, the x values must increase or decrease by the same amount. Here they're all going up by 20. I think in the last one they were going up by, what was it, 1? Yeah. They may have to make sure those are going up by the same amount. If they're not, we can't apply this rule. Okay? So, first thing we do are first differences to discover if it's linear. So we take the second term from the first, 1.77, subtract 0, what do we get? 1.77. Then we take 7.1, subtract 1.77, 5.23. Excellent. 15.96, subtract 7.1. What's that going to give us? 8.86?
8.86,
Next one we do are 28.38, subtract 15.96, 12.42. And then the last one, 44.35, subtract 28.38, what is it? 15.97, excellent. Okay, so, is this linear? No, these first differences aren't the same. Therefore, this cannot be linear. It's increasing by a greater amount every time. So what we then do from there is something called second differences. We take the values of the first differences and we subtract them. If they end up being the same, then we're going to have a quadratic function to the second power, okay? So what we're going to do, we take the first pairing, 5.33, subtract 1.77. That's going to give us 3.56. We take the next pairing. 3.53. So that's a little different. 12.42 subtract 8.86 is equal to 2? 3.56, I think. And then the last one. Okay.
Can you use like
3.53. Now, notice the difference is 3/100ths. So a very small amount. For the most part, all of these are pretty much the exact same. Okay? Remember, there could be some kind of rounding error when they're actually measuring these things. These are very, very close. So this is acceptable in saying that the second differences are the same. So therefore, if you're off by whole numbers, then you're probably no good. Even tenths. If you're off by many tenths of a number. But if you guys know this is 100th, this is a very, very small number. And it's not even very far away.
there's thousands and millions?
That's right. And if it's only those we're off by, then we're even more accurate. Okay? So, this is fine. This is more than acceptable to say that this is probably roughly a quadratic relationship. Remember, we're measuring something. We're not actually drawing a graph. We're measuring speed over braking. This relationship is roughly quadratic.
So if it's
Okay.
not the same though. It's not quadratic.
Then it's not. It wouldn't be linear or quadratic. If the second differences work the same, then it's neither. Okay? Because we're only going to focus on linear and quadratic relationships.
We did it last week. Oh yeah.
I know you did. Okay, so let's quickly discuss the domain and range of these two. Because x is our domain, what two values does it fall between?
0 and 100.
So how would I write this, Sherwin?
At square line x er.
Yeah,
The line
yeah,
0.
Yep.
That what I forgot what we call that. Yeah.
yeah,
Then x
yeah.
and 100.
Good.
Oh yeah.
So our speeds are essentially anything between 0 and 100. And our range,
0.
y-e-r. And what are the highest and lowest values?
0 and 44.3.
0. Stuff in between is identical, right? And 44.35. Okay? So there's our domain and range of these two functions.
And if they give you another y, the range would